To Reactions 2 by me, Rory Freeman. What are we talking about? This lab looked at the fundamental ideas of cations and anions and the roles that they play in precipitation reactions, in the hopes of becoming chemical constables who can work out the identities of chemicals from their unique behaviours when reacting in aqueous solutions. As you probably know, cations are the positive ions, anions are the negative ions, and a precipitation reaction is a chemical reaction where a chemical drops out of solution as there's a poor solubility in water. What did we do? The lab was split into two parts, Part A and Part B. Part A involved identifying an unknown cation, and Part B used theory to deduce multiple unknown chemicals. Part A started by taking 0.1 grams of an unknown chloride and dissolving in 100 centimeters cubed of water and adding 3 centimeters cubed of 6 molar nitric acid. 0.1 molar silver nitrate was then added until a precipitate formed, which was the silver chloride coagulating. At this point, an extra 5 centimeters cubed of the silver nitrate was added. The solution was then heated for 10 minutes, not allowing it to boil, and then vacuum filtered. The vacuum filter was washed with dilute nitric acid, and the washed solution was tested with 2 molar hydrochloric acid, and if a precipitate formed, it was washed again. The resulting powder was then dried in the oven and weighed. In Part B, we took about 1 centimeter cubed or a finger's depth of each solution and added it to the test tubes. Each other solution was added about 3 to 4 drops, and the observations were recorded in a table. Time to analyse Part A. This is quite maths heavy and our results didn't go very well, so we got this wrong. So, we started with a mass of unknown chloride, which was 0.1 grams. We knew that the mass of the filter papers we used was 0.2 grams, and the mass of the silver chloride and the paper at the end was 0.62 grams. This means we had a mass of 0.42 grams of silver chloride. The MR of silver chloride is 143.32, so if we add that to our mole calculation triangle as so, we get a mole amount of silver chloride of 0.00293. The moles of chloride is the same because it's 1-to-1, but the mass of the chloride in the unknown now exceeds the amount of chloride we had in the first place. So, we don't know. Anyway, on to Part B. I like to think of ionic reactions as a coliseum. You've got the gladiator ions that actually react and the spectators that aren't involved. An aqueous solution just means chemicals dissolved in water, which breaks them down into their constituent ions. Solids are reformed from the ions and therefore have no ionic charges. An ionic equation simply shows you what ions you start with in solution and how they end up. And any ions that are the same on both sides are the spectator ions and aren't involved in the reaction. Part B. This is the theoretical table of the reactions that we were going to conduct. In the next slides, I'll discuss what each reaction does and which ions just look on, doing nothing, also known as the spectator ions. Starting up with zinc nitrate, which was the first column in the table. The first reaction has no solid product, so every ion is a spectator ion. As with the second and third, all three reactions have all the same ions on both sides and no precipitate occurred. The fourth has a solid precipitate of zinc carbonate, which formed, meaning the nitrate ion and the sodium ion are the spectator ions. And finally, last equation, no precipitate, so every ion was a spectator. In column of lead nitrate, the first reaction produces no solid, so they are all spectator ions. The second produces lead iodide, which is a solid as it's insoluble in water, so the nitrate and potassium ions are the spectator ions. The third, they produced a lead sulfate solid, magnesium nitrate being the spectator ions. And finally, lead carbonate was formed, which is insoluble in water, so the nitrate and sodium ions are the spectator ions. Third column of sodium carbonate. In the first reaction, barium carbonate was solid, so the nitrate and the sodium ions are the spectators. The second reaction produced no solid, so all are spectator ions. And finally, magnesium carbonate was produced, which is a solid, so the sulfate and sodium are the spectator ions. And now, barium sulfate is the solid in this reaction, which means the nitrates and magnesium ions are the spectator ions. And in this reaction, everything's the same, so everything is spectating. But by no means least, lazy old potassium, iodine, barium, and nitrate ions all just sat round spectating, so nothing happens and there was no solid. Right, on to the deduction. Here is the actual table of results we gained in the lab. As shown by this arrow, this result would appear to be anomalous as it doesn't fit with any of the profiles, probably due to a dirty test tube. Using the theoretical chemistry and the actual results, we can finally work out that A is barium nitrate, B is lead nitrate, C is zinc nitrate, D is magnesium sulfate, E is sodium carbonate, and F is potassium iodide. And that's it. Thanks for watching.